for our quiz tomorrow in Block A. Okay, so we're going to be continuing with rationals. And this is actually a really good lesson because it kind of reviews everything we've done up until this point. So I'm hopeful that if you did have any questions or concerns, this will address some of them. And then if you have more questions and concerns, I'm just going to stay on and answer questions until the end of the day, basically, while you're working on your review and starting your Unit 2 portfolio. So let's get started on these examples. So the first one here, we're going to be writing the area of the rectangle in simplest form. Okay, so this part's really important, the simplest form part. So we just need to make sure that we simplify it as much as absolutely possible. So let's start by writing out the equation of our area of a rectangle. So we have our area is length times width. And just on my rectangle, I'm going to label my length and my width. If you labeled your length and width differently than me, that's absolutely okay. Just your answer will be the same. You'll just notice that your two terms are flipped. So now I'm just going to fill in those values. So my length was x squared minus 9 all over x. And we're multiplying that by x cubed minus 4x all over x squared plus 5x plus 6, like this. And now we're going to do our multiplication rules. So now that we have it set up, it's just like a question from lesson 2.2. So the first thing I do is I look to see if there's any restrictions I can see right away. And because I just have an x alone on the bottom, I can write x cannot equal 0 right away. And as we go through, we'll continue to add some more restrictions. Next, I'm going to factor everything I can factor. So I'm going to check each numerator and each denominator to see if I can factor anything. So my first numerator, x squared minus 9, is a difference of squares. So that factors to x plus 3, x minus 3. And our denominator x cannot factor anymore, so we just leave it as x. Then all of that is multiplied by our numerator, x cubed minus 4x. So I can factor out an x out of that. I'm left with x squared minus 4. And all of that is over. When I factor this, I need to find two numbers that add to 5, two numbers that multiply to 6. And those would be 2 and 3. And then because that first number is 1, I can just take that and put it right into my equation. Yes, Dimitri, you can put your question into the chat. Do you always have to factor? Yes. So anytime you can factor, always factor. There's no situation in which you won't factor. The only reason you wouldn't is because it's unfactorable. Great question. Okay, so now let's cancel some things out. So this cancels with this, and this cancels with this. And then we'll just continue on. So we have x minus 3, x squared minus 4. That's a difference of squares too. So I'm going to do x minus 2, x plus 2. And all of that is still over x plus 2. So now I can cancel some more things. Plus 2, x plus 2. And I'm just left with x minus 3, x minus 2. Now, the last thing we need to do is go through and make sure we have all of our restrictions. So from over here, I also have that x cannot equal -2 or -3. So there are all of our restrictions. And then, because this is a word problem, because I have words in my question, I also need to have words in my answer. So say, therefore, the area of the rectangle is x minus 3, x minus 2. And that's our final answer. Are there any questions before we move on to the next example? No, we're good? Okay, awesome. Let's do another one then. So our next question is that the area of a trapezoid is 6y squared minus 5y minus 6, and we need to find the height. So let's start by writing out our equation for the area of a trapezoid. So that's our equation for the area of a trapezoid. And this is how it's labeled on the trapezoid. So my top is going to be A, bottom's going to be B, oops. And then we're going to have H right over there. And then the next thing we're going to do, because we're looking for H, it's in our best interest for us to rearrange the equation first. So what we're going to do is we're going to move things around to get H all by itself. So we're going to have to divide both sides by A plus B over 2. So what that will give us is that H equals my area divided by A plus B all over 2. You can rearrange it once we already have all the values in there. But honestly, I think it is significantly easier if we rearrange it now than waiting until we have all of these crazy numbers going on. So now let's fill in our values. So my height is equal to my area, which from my question is 6y squared minus 5y minus 6 divided by, so I'm just going to sub in A, which we said was 3y minus 2, plus B, which is y minus 4, all over 2. And the other thing I'm going to add in here is underneath this, there's just a 1. So to make our lives easier, I'm just going to put that 1 under there, just as a reminder that we are dividing fractions. So now let's do some simplification, and we'll do some factoring and collecting like terms. So we'll start by factoring this thing. And I'm just going to do the factoring off to the side over here so you can all see where I get my values from. So 6y squared minus 5y minus 6. So we need to find two numbers that add to the middle number and two numbers that multiply to the first number multiplied by the last number, which would be negative 36. So those two numbers are going to be negative 9 and 4, negative 9 and 4. And now, because those two numbers add to negative 5, in the equation, instead of writing negative 5y, I'm going to put minus 9y plus 4y minus 6. And now I'm just going to factor by grouping. So we'll have 3y, 2y minus 3, plus 2, 2y minus 3. And then I can take out that 2y minus 3, 3y plus 2. And that is our fully factored expression. So now we can bring that back into our equation. 2y minus 3, 3y plus 2, still all over 1. And now for our second expression here, I'm going to be collecting some like terms. So that will give us 4y minus 6 all over 2. And now I'm just going to double check that there's no more factoring I can do. So I can actually common factor my other expression there. So I'm just going to quickly do that. And while I do that, I'm also going to flip them. So remember when we have two rational expressions and we're dividing them, we always flip the second one and multiply. So we flip the second one and we change that to a multiplication. There we go. So now I'm multiplying, so I can start crossing some stuff out. So I have a 2y minus 3 in the numerator and in the denominator here. And I have a 2 in the numerator and a 2 in the denominator. So all of this simplifies to 3y plus 2. And then I need to make sure that I have all of my restrictions. So if I look, the only time that we have a y on the bottom is right over here. So we just need to make sure we write a restriction for that. So that will give us that y cannot equal 3 over 2. And then because this was a word problem and we had words in the question, we need to have a therefore statement. So I would say, therefore, the height is 3y plus 2. And that's it. Are there any questions about that example? Hopefully that this is clearing things up a little bit from the past, I guess, day and a bit. We're okay so far? All right, so it doesn't seem like there's any immediate questions. So we will move on to our next example. We have 2 more examples to do, and then there's some practice problems for you. So let's do another one together. So for example 3, we're going to determine a simplified expression that represents the area of the ratio of the area of the smaller rectangle to the area of the larger rectangle. So basically, this is what we're trying to fill in. So our ratio is going to be equal to the area of our smaller rectangle divided by the area of our large rectangle. So when it says ratio, it's just asking for a fraction, right? And it says small to large. So that means small is in the numerator, large is in the denominator. Okay, so let's start by finding the area of our small rectangle. So it's a rectangle, so it's just length times width. So it's x times x plus 4. And all of that will be divided by the area of the large rectangle, which is 2x times 2x squared plus 8x, like that. And now let's take a moment to check for some restrictions. So we do have that x all by itself, so that means that x cannot be 0. And we can't really see the other ones yet, so let's just leave it for a moment and we'll get to the rest after. So now let's see if there's anything else we can factor. So the numerator we can't factor anymore, so we'll just leave that. And in the denominator, I can factor some stuff out of here. So let's factor some, as much as we can out of there. So we'll have 2x times, we can factor a 2x out of there, and we're left with x plus 4, like this. And again, we can see some restrictions here, so let's write those out. So we already have x can't equal 0, but we also have now that x cannot be -4. So let's add that in. Now, we can start canceling some stuff. So because everything's multiplied outside of brackets, we can start canceling some stuff. So we have an x here and an x here, so we can get rid of those. We have an x plus 4 and an x plus 4, so we can get rid of those. And what we're left with is 1 over 4x. So that is our final ratio, with our restrictions of x cannot be 0 or -4. And again, because this is a word problem with words in the question, we always need to make sure that we have a nice little therefore statement at the end. So I'll say therefore, the ratio is 1 over 4x. And it doesn't have to be like a really detailed therefore statement, just nice and to the point. Okay, are there any other questions right now? No, we're okay? All right. So let's try our last example that we'll do together. And then I'll explain your expectations of your homework and all of that stuff. Okay. So our next one, we have that 2 rectangles. Sorry, one moment. So we have 2 rectangles that have common sides with a right-angled triangle. And the areas and widths of the rectangles are shown as indicated. So we're going to write and simplify an expression for the area of the triangle. So this can be a little confusing, so I'm going to add some things to the diagram to make it a little bit clearer. So to start, we have this rectangle here, and we'll kind of color code it to make things a little bit easier for you guys to see. So our pink rectangle has an area of 2x squared plus 10x plus 12. So that is our first area, area 1. And the width of this rectangle is x minus 1. So in order to find some information on the triangle, we're going to need to find the height of the triangle. I'm just going to call that length 1 here. Now we have a second rectangle that's touching our triangle right here. And we're going to call that A2. And A2 has an area of 2x squared minus 3x plus 1 and a width of x plus 2. Now that will be able to give us the base of our triangle, which we'll call L2 like that. So now what we're going to do is we're going to start by finding the base and height of the triangle, or L1 and L2. So we're looking for L1 and L2. So let's start by finding L1. So my area 1 is equal to length 1 times width 1. So all of the pink values. But I'm just looking for the length. So I would divide both sides by W, and I'd get that L1 is equal to A1 over W1, like this. So now let's fill in our values with our pink numbers. So our length 1 is going to be equal to 2x squared plus 10x plus 12 divided by x minus 1, like that. And now we're going to start simplifying this. So I look at my numerator, and I'm going to start by common factoring because they're all divisible by 2, so I can take a 2 out of everything. All over x minus 1. We do already have a restriction, so once I finish doing the pink example, I'll add the restrictions in. So now I'm just going to factor that x squared plus 5x plus 6, which we actually did earlier this lesson. So that's just x plus 2, x plus 3. We did that in example 1 over x minus 1. And just like Ethan mentioned in the chat, we do have a restriction here. So we're going to go through and keep track of our restrictions as we go through the solution. So we have one restriction so far. So here we have that x cannot equal 1. And then at the end, we'll sum up all of our restrictions together. Okay, so we found the height of our triangle. And now let's find the base. So we're going to be looking at area 2. which is L2 times W2. Here. There we go. And we just want to find L2, so the base of our triangle. So let's rearrange our equation. So L2 is equal to A2 over W2, like this. And now let's fill in our values. L2 equal to A2, which is 2x squared minus 3x plus 1 all over x plus 2. Just make sure it's a plus. There we go. X plus 2. And now I need to simplify this. So I'm going to start by factoring the top there. So L2 is equal to, and I'll just quickly show you how to factor it. So we have 2x squared minus 3x plus 1. So I need two numbers that add to the middle number, which is -3. Two numbers that multiply to the other two numbers, which would just be 3. So now I need to think of my numbers. Oh, did I write this down? Right. Yep, so I have 1 and 3. That does not add to -3. Why is this not factoring right? Did I write it down wrong? Oh, it should be 2. Sorry. Thank you. I'm looking at it feeling like I'm going crazy. There we go. Never mind. Sorry. Brain's not working today. There we go. -1, -2, -1, -2. Now we're all back to figuring it out. So instead of writing -3, I'm going to write 2x squared minus x minus 2x plus 1. And then I just factor out as much as I can of each group. And then we have 2x minus 1, x minus 1, like that. And so we can fill that in. So we'll have 2x minus 1 and x minus 1 all over x plus 2, like this. And this also gives us another restriction, which would be x can also not be -2. So now we have the value of this, and we have the value of this. So now we can find the area of our triangle. And that is our last thing that we need to do. Step 2, find area of triangle. So my area of my triangle is base times height divided by 2. So my base is my green L2. So that will be 2x minus 1 times x minus 1 all over x plus 2. And all of that is multiplied by my height, which is L1, the pink one, which is 2, x plus 2, x plus 3, all over x minus 1, like that. And then all of that will be divided by 2. So now let's start canceling out some things inside the brackets. So I have a x minus 1 and an x minus 1, x plus 2, x plus 2, like this. And that will leave me, sorry, I'm just running out of room. So that will leave me with 2x minus 1, x plus 3, and all of that is still divided by 2. Oops, I lost a 2. Sorry. There we go. And now I can divide and cancel some things out. So what we have left is 2x minus 1, x plus 3, like that. And now let's just go through and find the rest of our restrictions. So I already have accounted for this restriction and this restriction. And that is it. So these are my restrictions for the whole thing. X cannot equal 1 or -2. And that is our final answer. So I need my little therefore statement. So I'm just going to say, therefore, the area of the triangle where do you see -3? It doesn't appear on the bottom of a fraction. Oh, no worries. I've already made one mistake. So honestly, please let me know if you see anything that doesn't quite make sense because it happens all the time. Okay, so the area of the triangle is 2x minus 1, x plus 3. And that's our final answer. So are there any other questions? Yeah, Sasha. So if it's division, you can, but we just have to do the flip the second one and multiply first, just so that you make sure you're canceling from the right sides. So if you have your two rational expressions, just make sure you flip it first, because sometimes it could be hard to know which ones actually cancel because there's one on the top and one on the bottom. So I think hopefully that answers your question. So are you referring to something kind of like this, how it was just one fraction that we were dividing here on this one? Yeah, so we can still cancel here even though it's one fraction like this. So we lost the x plus 4 and the x plus 4 and an x and an x. So anytime, so if that had division, oh, like within it. I see what you're saying. Like if I had divided by something else in it. Okay, got you. You could, but it does get a little tricky in terms of what can cancel and what can't. So what I would probably recommend doing in that case would be to write out the full numerator with all the extra divisions, cross out stuff there, and simplify that whole numerator first with the divisions and do that all on its own, and then put it back into this big fraction. If you end up having a question like that you found in the book, you can send it my way during the review time and I can help you with it in more detail. Okay, are there any other questions? So those are the examples that we're going to do. There are a bunch of practice ones for you to do below. I have done all the solutions and put them up on Classroom. There are some answers on the bottom of your page. The last one is incorrect. So look at my solutions, not that answer. I think it just forgot to simplify something. So if you're looking for the solutions, they're all in Classroom already. And then I'll post this video as soon as it is loaded. I'm going to stop recording now.